Hey guys, I'm back with, I'm going to start a video now on all of the volume by revolution problems now, so feel free to skip around throughout this video or skip between videos, but hopefully you'll find this helpful. Remember, if I'm doing a volume by revolution, we really have two cases. We have the gap case, and we have the cases where we don't have a gap. So really for all of these problems, I wish I had a little bit more room. I'll see if I can maybe squeeze this in at the bottom. We have these two cases. When there's no gap, we use the integral of pi big R squared, and when we have a gap, we're going to do pi big R squared minus little r squared. So when I revolve something, so like if you look at my fingers, if I'm revolving something, I'm making that shape of a circle. My cross sections are all going to be circles, and that's why we're taking the circle formula. When I have the gap, I'm essentially taking the volume of the larger solid without a gap, and then I'm subtracting out the volume of the gap. So that's what we're doing. Let's start up here with number 3. We want to find the region bounded by y squared equals 4x. I think we just saw it a little bit earlier, and y equals 2. It's being rotated around y equals 3. So let's just start by drawing a picture. Just trying to picture this really fast. So remember, this is going to be the y-axis. This is a horizontal line. So it looks like most of this is going to be in the first quadrant. Okay, so I'm going to have y squared equals 4x. Then I have the line, the y-axis, it's x equals 0. And then I have y equals 2. So I'm just going to kind of draw on, maybe that's y equals 2. And this is what I'm going to be revolving. And I'm revolving around the line y equals 3. So this was 2. This was 3. And in class I said that it can be helpful to highlight what we're revolving around. You won't get a highlighter on the AP exam, but for right now I think it can be just a helpful tool to help us figure out if there's a gap or not a gap. My region that's bounded by x equals 0, y equals 2, and the curve y squared equals 4x. And there's definitely a gap because this highlighted line is not flush against my area that I'm revolving. So this is going to be a gap problem. There is a gap, and we're going to have pi times the quantity big R squared minus little r squared. Well, let's see if we can figure out what these r values are going to be. Here's my closer, my axis to the closer curve. Here's my axis to the farther curve. So my big R is going to be this. My little r is going to be this. Well, normally the second thing we do is we do our bounds. So if I look at the bounds for this problem, I'm going to do everything with respect to x because I have a horizontal line, which reminds me of the x-axis. So I'll do everything with respect to x. Okay, well, I need to figure out what these are with respect to x. So I'm definitely starting at 0. I know that this is going to be y equals 2. So I could say, like, if I'm intersecting with this, if y equals 2, I'm going to have 4 squared. So remember, y equals 2. 2 is going to be where 4 squared equals 4x. So x has to be 1. So this point here is going to be 1. Let's see if I can do big R and little r now. Big R is going to be from 3 is the top, to this. And this is going to be, we haven't solved y yet, so let's look at this really quickly. We know that y squared equals 4x, so y is equal to square root of 4x. We just need the positive part. The negative part would be down here. So it's going to be 3 minus square root of 4x. Little r is the distance from 3 to 2, so it's just 3 minus 2, which is equal to 1. So now I can set up my integral for volume. I'm going from 0 to 1. Pi. Now some people, and I've done this before in class, leave the pi here on the outside. It's totally just personal preference. Because it's a constant, we can factor it out to the front. Okay, big R squared is 3 minus root 4x squared. So that's r, big R squared, minus little r squared dx. Okay, so remember when we type this into our calculator, and I know I didn't talk about this in first period, third period we talked about this, that when you leave your answers, if you're going to leave a pi, it needs to use an exact value, so like 9 pi or 1/2 pi. So you can put a fraction in front of pi, but you can't leave your answer as a decimal pi. So here's the 2 different ways you could leave your answer. I'm going to not type in this the first time. We're going from 0 to 1. Again, I'm not going to type in pi this first time. Check it all in there. So let's look at this number really fast. Remember, our calculator sometimes has a little bit of error. If I were to round, so this is actually going to be a value of 2. So remember, I didn't type in the pi, so one way I could leave my answer would be 2 pi. Or I can multiply my answer times pi and put it in there. So either of those answers would be acceptable, but I should never put a rounded decimal in front of pi. Okay, let's move on to number 4. It says find the volume generated by revolving the area enclosed by y equals negative x squared plus 4x and y equals 2x about the line y equals 6. So I'm just going to look at this real fast and realize that this here is the same thing as I'm going to factor out a negative x. I have a leftover x minus 4. And then y equals 2x. So if I were to sketch this real fast, I notice that I have an upside down parabola that's going to be crossing at 0 and 4. And then I also have the line y equals 2x. Now, I don't know exactly where that's going to cross. I don't know if this picture is perfect or not, but I know I have this point here and I have this point here at 0, 0. This is going to be the region enclosed. And we're rotating this around y equals 6. So let's start by finding my bounds. In this case, that's going to be my intersection points. Okay. So I want to know where the line, or sorry, the parabola, negative x squared plus 4x is equal to 2x. Okay, so let's simplify this really fast. I'm going to have, a negative x squared plus 2x equals 0. So if I factor this, that's going to give me a negative x minus 2. So that means my bounds are going to be from 0 until x equals 2, because that's what makes those 0. Okay, well, when I look at this, I notice I am going to have a gap, so that means I'm going to have my 2 r's. So my little r is going to be the distance from here to here, and then my big R is going to be the distance from here to here. So if we want to write these out real fast, we could say, well, we know that big R is the farther distance, so it's going to be from 6 down to this line here, so that's going to be 2x. Little r is the distance from 6 to the parabola. You can simplify this out, but sometimes it's better just to not make mistakes when you're distributing that negative. So now let's see if we can write my integral expression. My volume is going to be equal to the integral from 0 to 2 pi, and again, that pi can go on the outside if you want, big R squared minus little r squared. Now if I did distribute, that's going to give me a positive x squared. And if I distribute, it's going to give me a minus 4x. You don't have to just out of parentheses otherwise, but it's better to have parentheses than make a mistake with the distributing. Okay. Do math 9. I'm going to go from 0 to 2. I'm going to do it without the pi first. Make sure my parentheses are all good. We got one too many in there. So we don't want to put 9.6 pi. We can either write this as 48 pi over 5. Or we could take this and we can multiply it by pi. So do one of those, but we don't want to have a decimal, especially if it's a rounded decimal in front of pi. 9 is exact, but it's just better to get in the habit of either doing it with the fraction that's exact or putting it with the decimal. Okay. Let me look at these next two problems real fast. Be nice to do one. Let's see. Any dy's right now, so I'm not going to do 5 and 6 for now, but I am going to make another video starting with the cross sections. Okay, so stay tuned for another video.